Welcome dear students. This is an online class for the program BCA of 3rd semester. In this online class, we are learning on the subject System Software, which is affiliated to the Kuvempu University syllabus. So today we will start with the session number 11. So let us see what we are going to learn in session number 11. So today we are going to discuss about unit number 2 of System Software, which is discussion about assembler and loaders. So these assembler and loaders, these are the most vital system softwares which is been used in the computer system. So the title or what content we are going to learn today is we'll get introduced to assemblers and loaders. Then we'll come to know about the general and procedure of them. Finally, we will learn about the design of assembler. So before starting today's session number 11, let us just recap, have a recap of session number 10, what we had pertaining to unit number 1 of system software. So in the last session, you have understood the random entry searching algorithm, how it is going to learn, and with an example you have described this random entry searching. So for today's class, the learning objectives include: first, the student has to or you will be able to understand the introduction of assemblers and loaders and their general design procedures along with the design of assemblers. The session for this is the student will be able to understand the introduction, general design procedure and design of assembler. So let us get introduced to the system software called as assembler. See, this assembler is a system software which is used to convert any assembly level program to its equivalent object code. Normally, this assembler is most widely used system software when we enter into the era of programming there. So this assembler system software, so it is meant for converting any assembly language program to its equivalent object code so that we can go for further execution of the program. The input to this assembler is nothing but a source code written in assembly language. Normally the assembly language will be written using some mnemonics. So in the next slides I'll be telling you the examples for the mnemonics, and the output is nothing but the object. The design of an assembler depends upon the machine architecture. The language used is mnemonic language. So this is one of the things which everyone should keep in mind, that the machine architecture plays a vital role when we are discussing about assemblers. So there is a diagram. In this diagram, see that in the middle we have an assembler, and for that as an input we are giving the source program that can be a mnemonic opcode. Opcode stands for operational code. Maybe any of the symbol from your language. Okay, so the assembler will take these as input and it will convert them into something called as object code, which is necessary for the further execution of the program. See, now let's see what are the basic assembler functions and what is going to do. The first one, see, assembler, it is used for translating mnemonic language code to its equivalent object code, and this is the fundamental function of any assembler. Also, it is in assigning the machining address to the symbolic labels. Then the design of an assembler can be performed with the following. So when we are going to design an assembler, we need to follow some steps. So we will be discussing here those steps there. The first step is performing the operation called as scanning, or technically it can be called as tokenizing. So once scanning or tokenizing of the file is done, then we have to go for validating the scanned out instruction, which is called as parsing. Later, we need to go for creating the symbol table, which has all the details about how many symbols we are going to use in the assembler instructions. So next, we have to resolve the forward references if we encounter in a symbol table. So finally we are going to convert it into a machine language. So these are the 5 things to be performed when you are designing an assembler. So now let's see the general design procedure. So following are the steps that should be taken care by any designer while he is designing an assembler, and these becomes the fundamentals for designing any assembler there. So the first one is here, when you go for designing the chair, first the foremost thing is you have to specify the problem. So once you're clear about the problem, then you can go for the upcoming steps. Next one is, once the problem is obtained, you have to define or you have to specify what data structures you are going to use for the designing of an assembler. So you can use either a linear or you can use a non-linear data structure based on the requirements. Once you are familiar about what the data structure has to be used, then you have to define the format of every data structure there. If it is a tree, how it should be, or if it is a linked list, how it should be. So once we are done with the format, then we have to specify the best algorithm for designing an assembler. So when you're designing the algorithm, the most important thing is in our next step, that is to look for the modularity. The algorithm which you are used, which is very modular in implementing any assembler there. So then we have to repeat the step number 1 to 5 on every modules. So this is the general design procedure for designing an assembler. Next, when we are thinking about designing of assembler, see, every assembler has to perform some addressing. In the previous slide, I said about forward references and all. So normally, we have different types of addresses when we go for the process of designing an assembler. Which are those and what are those? Let us understand. The first one is, we have addressing options. Among them, the first one is absolute addresses. So these absolute addresses we have learned even from our programming in our operating system everywhere. In the same way, these are the address fields that will not require to be customized by the loader. So directly they will be given. Second type of addresses is reallocatable addresses. These are the addresses that will require to be accustomed if and only if the loader chooses to position this program at a dissimilar location than the assembler allocated. So as the name only is specifying, it's a reallocatable. If the assembler has given a location and if there is a need to be reallocated in some other place, then we are going to use the reallocatable addresses. Third thing in this design issue is externally defined symbols or labels. See here, the assembler does not recognize the addresses or the values of these symbols, and it depends on the loader to locate the programs comprising these symbols, then loading them into memory, and the position the addresses of these symbols in the calling program. Then the next one is the indirect addresses. The addresses refers to a location in the memory that comprises the target address. This is called as direct address. And we have a direct address where the address of an explicit position is in the physical memory itself. So that we call it as a direct address. Same way we have immediate addresses. The normal addresses will be utilized for an immediate value instead of an address. So here we can have an integer value which can be added to an address that can be called as immediate addresses. So now we came to know about the introduction of assemblers, its design procedures, and some of the concept in it. So regarding the session what you have did, let me have a MCQ for that. So the first one is an assembly is we have 4 sections there. One, it is a utility software, application software, system software. None. The answer for this is, I think you all have guessed properly. Yes, it is a system software. Good. So now we'll move on to the second one. Assembler is a machine dependent because of what? So because it has a MOT, that